Hey guys, so in this video we are going to cover the next topic, which is packages. Check quickly. All right. So what are packages? In very simple terms, I would just say that package is just a folder, just a folder where you can have Java classes and folders or packages. Okay, it's that simple. So what is a package? Package is just a folder where you can have many Java classes. I should say many Java classes and many folders. Like for example, in your computer you would have simply like you would have these folders, right? You have seen these folders. This is your home. Inside home you will have documents folder, right? You have this documents folder. You have this downloads folder. When you download something from Google Chrome or Edge, you will have a downloads folder. Then you will have a video folder. Then you have a maybe music folder. Then you have pictures folder, right? You have all this pictures folder, right? You have these things, right? Now even then, even within them, you might inside, let's say in pictures, within pictures you might have another folder, say screenshots, right? Screenshots. You have this folder. Then maybe you have another folder, say maybe photos, or maybe you use the webcam of your laptop. So webcam, this will have photos which you have clicked using your laptop's webcam, right? So and within this you will have files. You have screenshot, maybe 001.jpg, 002.jpg, something like this. Okay, and again you inside the webcam you will have some pictures, say xyz.jpg, or maybe say abc.jpg. So point is that whenever I'm talking about the child elements, like the last elements, these are like your Java classes. Okay, like your Java classes. Okay, and these are what is this, by the way? This is a package, right? This is a package. A package can have many other packages. This is the package, this is a package, this is a package, this is also, and this also are packages, right? And within packages you can have another packages. This is package, this is package, but this is the Java class, this is another Java class, this is another Java class, this is another Java class. So whenever I'm talking about packages, it works on the same concept of folders and files, right? The files are basically the Java classes and the folders are the packages. That's it. And why do we need folders? Like, forget about packages. Why do we need folders? Of course, to organize things. Of course, to say for example you have one large folder and you keep your documents, downloads, videos, music, pictures, everything into this one folder. Won't it be very cluttered? It will be very difficult. It will be very difficult to find things, to work with things, to search things. It would be very difficult, right? If everything is inside only a single folder, it would be very difficult for you to search things, right? So that is the reason we have all these folders, to distribute things, to divide the things. Okay, this folder is only for the documents, this folder is only for the download, this is for videos, music and pictures. To organize the things differently. That is the same reason inside a library, you have many sections. This is for fiction, this is for non-fiction, this is for sci-fi genre. I mean, you have all these. This is for biographies. You have these divisions, and within these divisions then you have another division. Say maybe this is for kids fiction for 8 to 10 years of old. This is for maybe 12 to 18 years old, like that. And then you have the files, like the books. These books are the Java classes. Okay, think of these books as the Java classes. Okay, so that is the thing. In Java also you have all these, you have a lot of packages that are already built. Let me give you some of the examples of those. So you already have used the scanner class. You have used the scanner class. You have used the IO class. I remember input stream buffer, the manual way of taking inputs. You have used IO there. Then you have the math class, then you have the string class, all these things, right? All these are what? These are Java classes. These are already there. Okay, you don't have to write all these things. These are already there in Java. So where are these located? Where are these located? So the thing is that inside Java, I mean, let's say this is the Java ecosystem. Okay, this is the Java ecosystem. This is where everything related to Java is there. Okay, this is your JDK or something. Now now there is a folder called Java. There is a folder called Java. Okay, within this folder you have another folder. Let me mark it with another color. You have util. This is another folder, util. Within util then you have scanner. So this is the reason, this is the scanner class. This is the scanner class. Okay, okay, this is how it looks like, scanner. So and then you have also used the math library. Recently we have used math library. So where is math library? Math library, by the way, is in another, this is the Java folder. Within Java folder you have, for example, say lang folder. Okay, lang folder. Within lang folder then you have the math class. This is the reason that you write something like this. Import, first you write the top folder name. What is the top folder? Java. Import Java dot, what is the next folder? So for example, I want to import scanner class. What is the next folder? Util. Java dot util dot, and what is the class that I'm going to use? Scanner. Java dot util dot scanner. This basically means that I want to import, I want to use the scanner class which is located within the util package, which is located in the Java package. Okay, this is called the top package, this is the intermediary package, and this is the class. Now util can have many things. Okay, util has something called a system class also. Util has I don't remember correctly, yeah, IO class as well, right? Java.util.io. You remember java.util.io? So all this lang has math, it has string. Okay, so what are these used for? Well, scanner is for input. Okay, input and output and everything, right? And then you have the system. System is for system information, for example, maybe RAM, CPU cores, and storage, etc, etc. If you want to work with these things, RAM, CPU, storage, let's say you want to see how much space remaining in your RAM, what is the percentage of your CPU utilization, how much storage you have used in your hard disk. All these things can be found using the functions, the methods that are defined within the system. system class inside the util package, which is inside the Java package. What is IO? IO is for again input output and for doing file handling stuff. Maybe create a file, write to a file, read from a file. So all this stuff are done using the IO class. Okay. Then what about this math? Of course, for handling math operations, right? Like sine, cos, tan, and absolute, mean, maximum, etc. Strings are for use for string manipulation. We'll look into that in a later video. But yeah, the point is that you have all these classes stored within many different packages. Packages are nothing but just folders, nothing more than that. Okay, just folders. These are done for categorization. Now, do you have anything else other than this lang and util folder? Yes, we have, but I'm not going to detail. Do you have something other than the Java top folder? Yes, we have something called as let me remember. Yeah, you have something called the Javax top folder. Okay, and I'm not going into details what are inside this. There also you will have many different folders and all, and you will have many different classes and all. Okay, you will have classes. You will have many classes over here. This is another top folder. This is used for desktop applications. Desktop applications means say you have a banking application where you have to do something, maybe check what's your balance or something, like your mobile apps, right? Mobile apps and stuff, that inside a desktop, inside your computer. This was used previously when creating desktop applications inside Windows and Mac. Okay, so this is why it was used, Java applications. Let me give you a demo actually quickly. Let me open. Let me show you the images actually. Do you see something like this? Student registration, some application like this, first time, last time, something like this, some buttons, and these are the things where you need to use the Javax folder. Okay, the Javax folder. Okay, and inside Javax folder you will have these components like this is a class, this is a class, this is a class, this is a class, this is for taking the password, this is for taking the input, and all these things. These are the components that are the classes inside the Javax. Okay, so these are the things. Yeah, see, for example, if you want to create a calculator like this, calculator exactly like this, then you would need to use this Javax top class. Okay, what are some other packages? Oh, I forgot to mention. Say you want to work with network application, then you have also another sub package. Oh, by the way, just for your terminology, these packages, okay, these are the child packages. These are called the sub package. Sub packages. Okay, sub packages. Okay, and these are the parent packages, or sometimes they are called as super packages, or not even super packages. Just call them packages. Okay, packages. These are just packages, and these are sub packages. Why? Because these are child packages. If you have another, say for example, you have, yes, of course you can have other folders here also, so these are also called sub packages. These are not called sub packages. Even these are called sub packages. Okay, and even if this has another child, this is also called sub packages. So folder is another folder within another folder is called a subfolder or a sub package in Java. And yes, you can have many other folders. You can have something as java.net dot something something dot something something dot something something, and this can go on. Okay, so anyway, there is actually another class, there is actually another package in Java within the Java package, that is called the net sub package. So what does net sub package do? It works with the network things. For example, you want to check what's your internet speed, what is your internet speed, or your download speed, upload speed, and everything related to the network things. So there is a specific package to that, and you can import this by using the same methodology. You can say java dot net dot whatever the class name is, you can write and import it. So that's how you need to organize things within packages, because at any given point of time when you are creating a software, in fact all the big softwares in the market, right, they all have an entry point, right? And I am not going into specifically, I'm not talking about specifically Java, I'm talking about all the languages. Okay, whenever you are creating a software product, say using Python or Java or C++ or whatever, okay, whatever, they all have a starting point. This starting point is called the entry point. This is called the entry point. Like just like we have been coding for a while now. When we have started actually object oriented programming, we have started coding like this, right? We have an entry point, then the entry point will import some packages. This package will have another package, this package will have another package, and that will be used inside the entry point. That is the reason, because think about this, okay. Say for example you have the Java package, and you have the say lang package, and within the lang package you have the math class. Just for once, imagine you are trying to find a reciprocal of of uh, of an equation. Someone has told you to write a program to find the reciprocal of an equation. Okay, this is your problem. Your problem is not to write math class. This is already written. Okay, this is already this has cos, this has tan, this has sine, and all these things. Okay, you don't have to write these methods. These are already written. These are not your concern. Should not be your concern. Okay, your concern is creating this, using this. That's fine. But think about it for once, that all the logic, okay, how the cos method is written, how the tan method is written, all the bodies of the methods are written inside this. Okay, say this is math class, it is written inside this only. And by the way, math, let me check once. I last time I remember math class is a huge class. Let me see if I can actually show it to you. Maybe VS Code. Let me try and check actually. Let me try to import it actually. Import java.lang.math. Will this work? Let me show you actually. The math class. I cannot open it directly, but yeah, math class is a huge class, maybe 200 or 300 lines of code. Okay, 200 or 300 lines of code. Math class itself is that big. Okay, so for example, this is your source file. And only math library has 300 lines of code. We call it LOC, lines of code. And you write your problem, hypothetically speaking, say your problem is another 300, say 200 lines of code. So now if everything is written inside only a single class or something, so what will be the total lines of code? Of course 500 lines of code. Of course this entire thing will be 500 lines of code. And what's the problem with that? Of course it will be very messy. It will be very messy. Say for example, there is, hypothetically speaking, there is some issue in the cos method. You have to go through all the 500 lines of code to find the cos method, and then you have to update it, then have to make things right. So think about going through all the 500 lines of code all by yourself. That would be a difficult task. But say for example, you know that there is some problem in the cos method, you can go into only the math class. You know where is cos method, you can update it, you can make things right. You don't have to make any changes over here, it will automatically work now. Okay, you don't have to go in and make go through all the 500 lines. Why? Because you're separating things out. You no longer, if you work like this, you no longer have 300 lines of code, you only have 200 lines of code, only have 200 lines of code. Because this is your problem, writing this is not your problem. And even if there is some issue inside this method, you can come in here and fix this, and that will solve the issue over here. You don't have to put everything into a single file. That is the whole point of creating a software, right? So you have to divide the things, you have to organize the things like accordingly. So you have the entry point, this is your source file, this is where the program starts. Okay, then this program will take up many packages, many classes and everything, and these packages will have another packages, some other packages. This will have sometimes directly Java classes, you know, sometimes directly Java classes, sometimes Java classes only, sometimes only package, and then those packages will have Java. You know, this is the structure basically of a software. A software, when you create a entire big software, think about Netflix, think about Amazon Prime, think about all these big things. I'm talking about those big things. Okay, there you have structures like this only. You don't have only a single file and you write 1000 10,000 lines of code and it works. It doesn't work like that. This is not a software, this is not how a software works. You cannot have only a single source file and all. Let's say for example, oops, lol, my open board crashed. Oh, let me open. It has 44 pages, right? I guess that's why it is taking the memory up. Yeah, I was over here, right? Yeah, over here. Let me open it up. Yeah, so I was saying, you can have a single source file and you can write tens and thousands of lines of code and it will work. Of course it might work, but it will be very difficult. Say for example, on line number 1,45,000 you have some code error. Imagine you have to find that bug first. Your brain will not even work. I mean, it's very difficult, right? So that is why you have to you know, organize those things accordingly. So that is the requirement of packages, and we already have a lot of packages in Java. But sometimes, for your own sake, say for example you're working with multiple classes and all, you have to create your own packages as well. So packages are what? Packages are just folders. So let's create some. Okay, so let me create a folder over here, fresh new folder. Okay, let's call it Java. Okay, this is our Java folder, and now let's create some more folders. Say for example, oh, first of all, create a just a normal entry point. Okay, just create it first. You need the entry point, right? You agree with me, right? You need the entry point for this. So just create the entry point first. You can say, what was that entry point, right? Entry point dot Java. First create it. Okay, and continue. This will be outside of everything. This is not going to be within a package. Entry point is never within a package. Other things are within a package, but entry point, where your code starts, it usually doesn't reside within a package or something. So now create folders. Say call this maybe rabbit or something, a rabbit, and let's make another folder, call it elephant. These are packages. That simple. These are packages. Let's create some other packages inside rabbit. Let's say inside rabbit, let's create a Pokemon, I guess. Pokemon, and yeah, I mean, you need more folders for this, I guess. Yeah, okay. let's create Beyblade. I can't think of other names. So anyway, so what's our top folder? This one. This is our entry point. And within elephant, now let's create, let's just create things. Let's create a Java class or just Java file, and let's call it touch. And let's call it demo a dot java. So this is the class. We have demo a dot java. Okay, let's go back. This, we have rabbit. Inside rabbit we have two folders. Say for example, inside the Beyblade folder, let's create a Java source file. Let's call it demo b dot java. Okay, then let's call demo c dot java. Okay, we have two files over here. And inside Pokemon, let's create another file. Let's call it touch demo d dot java. So let's see the hierarchy ones. Okay, let's go to the top folder. Okay, and let's see the hierarchy. Yeah. Okay, so this is the hierarchy. So first of all, within Java folder, you have the entry point.java. Of course, you can see at it. Then you have the elephant folder. Within elephant folder, you have a Java class, demo a. Then you have the rabbit folder. Okay, within rabbit folder, you have the Beyblade folder and the Pokemon folder. Within the Pokemon folder, you have only one Java source file, that is demo d. Within Beyblade folder, you have demo b and demo c. Okay, you can have these things. Now, interesting thing is that can I have another demo c.java within Beyblade? Can I have it? No, because if I try to make another demo c.java within Beyblade, this demo c.java will get replaced. Why? Because there is already demo c. Already there is demo c. I cannot create another demo c. But can I create demo c within the Pokemon folder? Can I do it? Well, let's try it out. Let's go to the what was the folder? Rabbit. Then let's go to Pokemon folder and let's try to create demo c dot java. We have created. Let's see the tree structure once. Tree. Now do you see you have demo c within Pokemon and demo c within Beyblade, and these two are different. This is another reason why sometimes you might have to use packages. You might have classes with the same name. You cannot have classes with the same name within a single folder, can you? You can't, because the moment you create another demo c, this will get replaced by that. You cannot have. But when you have two different folders, then of course you can have a demo c over here and demo c over here, and these are different. You know that. Why? Because they are not clashing, they are in different folders, and you can absolutely have that. Okay, so this is the structure. How do you compile these type of Java programs, right? Let me open the VS Code quickly so that I can show you. Code dot, you have this, you have entry point.java. Let's create it out quickly. This would be public class entry point dot, okay, this one. Then you have a public static void main string args. And by the way, the only the entry point has this method, okay? No other class will have this method. Usually not meant to, the other classes are not meant to be run directly. This is where your program starts. So this is the only class, only Java source file that where you should declare the main method. Of course you can declare in other places also, but that is not ideal. Okay, so let's have this. We are done. Let's go to the elephant folder. You have the demo A, right? Demo A. Okay, so you will have public demo A, and yeah, that's pretty much it. Public class demo A, something like this. Now the moment you try to save this is showing something. The declared package does not match the expected package elephant. Why it is saying so? Because it can actually see that it is inside a folder elephant, but you haven't mentioned that anywhere. So whenever you put a Java file within a folder, you must mention the folder name before declaring the class. So basically you can fix this by saying that this is within the elephant package. Simple, that's it. You have to mention what is the folder name where this Java file exists. So this Java file exists within the elephant folder. That's why you have to mention package elephant. And see this is okay, no issues at all. Let's go back to Beyblade. You have Pokemon also. Let's go back to Beyblade. So now if I try to do the same thing, public class demo b dot java. Oh, not Java, sorry. Even this is also giving me an error. This is saying the declared package that I haven't declared at all does not match the expected package rabbit.beyblade. See, it is actually finding that hey, demo b.java is declared within Beyblade folder, which is within the rabbit folder. That's why it is saying rabbit.beyblade. So it is basically saying that your package should be rabbit.beyblade. So mention it, bro. So let's mention it. So what is the top folder? Rabbit. What is the subfolder? Beyblade. So write it like that only. Sorry, not import. You have to mention package rabbit dot, what is the folder here? Beyblade. Now it is correct. Right? Similarly, even here also, you cannot just say public class demo C. You cannot just do that and save it. Again, it will ask you to mention the package name. So what is the package name? See the red ones, these are the package names. So the package name would be rabbit.beyblade only. You have to say package rabbit.beyblade. Now it is correct. So this is how you are categorizing. And why is this important? Why do we have to mention this? I will show in a while. So let's save this and let's move on to the next one, demo d.java. Again, in this case, you have to first write package. What is the folder? Rabbit, and then within that you have Pokemon. Within rabbit you have Pokemon. So you have to write rabbit dot Pokemon. Once you do this, then you can write public class demo d. Have this. Great. Now here is the interesting part. Remember I said you can have same class names but in a different folder. See, for example, this demo C and this demo C are different. Why different? Because they are in a different folder. Let me close all these. I just want to focus over here. So public class demo C. and that's it, done. But again it is saying mention the folder name. What is the folder name? Rabbit is the top folder. Within that you have Pokemon folder. So just mention that over here. Mention that over here. Package rabbit dot Pokemon. That is how you can have multiple classes with the same name, because now it can differentiate. Java can actually differentiate that this is also demo C, this is also demo C, but this is in a different package and this is in a different package. This package is basically rabbit.web. Let me put it over here actually. Yeah, do you see the declaration is same, public class demo C, public class demo C, but how would Java understand that they are in a different folder? Using this only, rabbit.wavelet, rabbit.pokemon. So they are in a different package and they can have the same class name. Got it? That's how we can have same class names but in a different folder. That would basically avoid the name clashes. You cannot have another. Let's try to create something actually. Let's try to create another demo c.java. It will not let you create. Why? Because it already exists over here. You cannot do that. Okay, so that is the problem which you can overcome using this package concept, because these are in a different folder, and creating the same class, like creating the class with almost the same class names is allowed when using in different packages. So yeah, that's it. Now there is another catch. While compiling this. How do we compile this? Let me close all these things. How do we compile all the classes? Let me quickly open the the command line and look at this carefully. Let's first, where are we at the moment? We are at the Java folder, which is our parent, the topmost folder. Within Java folder we have the entry point of our software, which is entry point.java. It is pretty simple to compile this. How do we compile this? We call the javak and we call entry point, and it works. You can see it has been compiled. I am not running it using Java entry point because this is empty. This main method is empty. Anyway, it won't do anything. So no point, right? So what's the next step? How do we compile? Let's close this out. How do we compile demo.java, which is inside the elephant folder or elephant package? How do we compile this? You cannot say something like this. You cannot go into elephant and then you can call the Java compile. If you do this, this might or might not work. Okay, so don't do this. Don't go into the elephant folder and then compile. Don't do it. Go back, stay where you were and compile. Now you will say, how do we compile? Simple. You have to say javak. You have to say elephant / demo.java. If you do it like this, it will make sure that you can access it using the package. See, this is the byte code actually. This is the byte code. Okay, this is not the Java code. This is the byte code. Oh, by the way, another thing. Do you see the byte code? What is this? I haven't defined any method. Like if I go back, I have only defined this much. Where is this coming from? This is the constructor, but I haven't defined any constructor, and this is the default constructor that I always talk about. You don't create it. When you don't create any constructor, the default constructor automatically appears over here. This is why it is called the default constructor. When Java compiler says that you haven't defined any constructor, it gives you a default constructor like this. This is the default constructor, and this is, by the way, bytecode. This is after compilation. Okay, this is before compilation. Anyway, let's so we are done compiling this. So how do we, if say for example we had to run this. Okay, let me for a while say public static void main string args, and then you say system dot out dot println hello from demo a inside elephant package. How do I run this now? This has, first let's compile again. Compilation done. Now how do you run this? From over here? How do you run this? Can you just say Java? You have already done the Java compilation. Okay, this is done. Now how do you run this? Now this has main method. You can run this. Can you simply say demo.java? Will this work? It will not work. Since you have mentioned that it is within the elephant package and it has compiled like that only. If you see the compiled code, this is the byte code, by the way, you see that it has written package elephant over the head. So basically what I am saying, to run this now, all you have to do is to say Java elephant dot demo a. This will make sure that I am running the demo a within the elephant package. Now when you hit enter, it will work. Hello from demo inside Java, inside elephant package. That's how you compile a package, like a class within a package, and you run a class from within a package. Okay, let's compile the other fews so that you get an understanding it, and you can absolutely skip this part if you like you don't need it, but I'm just saying this for a general overview. Let's compile demo b from here only. Don't go into the rabbit folder and then try to compile and this. Don't do that. Just stay here and try to compile this. How do I compile this? You can say simply Java Java compiler rabbit slash Beyblade slash demo b dot java. Compilation done. Similarly, Java rabbit Beyblade demo c dot java. This will get compiled always, but let me just, for the sake of completion, let me define a public static method here just to show you the thing how it is working. Public static void main string args and system.out.println and simply say hello from demo c inside rabbit Beyblade, and let's do the same for that one also. This there is another demo c right over here. Hold on, over here also you had demo c. Yeah, or for this also let's paste this up. Yeah. And just change this to Pokemon. Save this. Okay, and let's compile these two these again. So demo c.java, let's compile this. Compilation done. Perfect. Okay, all right, let's compile these two. How about compiling this demo c.java? You already have compiled this one, but how do you compile this one? Compile Java rabbit not this one, rather this one, Pokemon demo c.java. Compiled. Similarly, demo.d.java as well, and this is done. All of them are compiled. Now see how Java differentiates. If I try to run this demo C, how would I run this? If I try to run this demo C, how would I run this? And if I try to run this demo C, how would I run this? Let's try. I would simply say these are all compiled. I can just call the Java interpreter, or basically the Java JVM, and make this run. I can say Java run rabbit dot Beyblade dot demo C. If I do this, it will say hello from demo C inside rabbit Beyblade. So you know that this is running. This is running. And how do you run this? Say Java rabbit dot Pokemon dot demo C. Now it will say hello from demo C inside rabbit Pokemon. So now you know that this is running, not this. This is how you can have the same class name within different packages. And how do you import all these packages in your entry point? Because of course this is your software, right? This is where your software starts basically. So how do you import all this? Very simple. Say for example, I want to import this Pokemon, this Pokemon over here. How do I import it? Let's try. Import rabbit dot Pokemon dot this one demo C. Consider demo C. That's how you import it. Okay, this is now import. Perfect. Done. Cool. And how do you import everything from say from Pokemon? How do you do that? Then simply say rabbit.pokemon.star. Star means you import everything. Everything means class C and demo D. Demo C and demo C. You import both of them together. That's how you do it. Okay. Now you can actually let's say if I define something like this. Let's say let's remove this for the sake of completion. And let's say you have a method public, and yeah, let's create a static method for the time being. Static void demo C example. Okay, and this only says system system.out.println hello from demo C inside rabbit Beyblade. Okay, done. And let's have the same method within this demo C also. Let's try to do that. Okay, you have this, I have this also. Okay, all right. So I have to change one thing. This is from Beyblade. This is from Pokemon. Yeah, right, perfect. Let me close all these things. Let me recompile things. Okay, let me quickly recompile things. Compiled. Okay, both the demo C classes compiled. Now how do you import these things? What if you import both the demo C? Import, say for example, import rabbit dot Beyblade dot demo C. Okay, and you also import rabbit dot Pokemon dot demo c. What will happen now? Now it will throw error. Now it will say the import rabbit Pokemon dot demo c collides with another import statement. Okay, it collides. So what about this rather? What if I say, not this, I'm sorry. What if I say import rabbit dot star? Like import everything. Import everything. Okay. Now if I try to do something like this, demo C. Now do you see this? Now do you see when you are talking about demo C, you have the demo C from rabbit.wavelet, and then you have a demo C from rabbit.pokemon also. Okay, demo C example. Let's call this out. Now did you see what happened? Now did you see what happened? Since, let me go back once. The moment you were trying to call demo C dot demo C dot demo C example, something like this. If you just do this, what will happen? It will say I cannot find demo C. So how can you fix this? You cannot call directly demo C. So you would have to write Beyblade dot demo C. Will this work? Beyblade cannot be resolved. So this will be a problem basically. You cannot do this thing. So how about we do something like this? Demo dot this one, demo C. So you are given two options, either call this or call this. The moment you click on one of them, say for example I'm clicking on rabbit.pokemon, see the first line of the code. Do you see what happened? The moment you click this, an individual statement will appear over here. So basically you can either call the demo C from Pokemon, or you can call the demo C from Beyblade. You cannot call both. If I try to do something like this, import rabbit dot Beyblade dot demo C, something like this, this will not allow me. Because eventually if I try to do this, I will call demo C. Now the compiler will be confused. Are you talking about this one or this one? So when the class name is same, basically you can only use one of them, not both. That is the concept of this. Will collide and this will not work. This will not let you work. Okay, so that is something you have to be careful about. Anyway, let me remove all these things. Yeah, so that's how you import things. Okay, for example, another thing that I want to share. Say for example you have another class over here. Within the entry point only, you have another class, say class C. You have class C also, and demo C. Yeah, class demo C also. And here also you have the same method over, say, Pokemon class. Not this one, of course. It's the compiled code, right? Yeah, let's copy this out. Go back to entry point.java and let's paste this. In previous videos, I have shown that you can have multiple classes within the same Java source file, but anyway it will be splitted up. Anyway, when you compile this will create another class, okay, inside entry point. Okay, if I try to compile this, how do I compile this? Simply, this class is within entry point only, just recompile entry point. You can say javak entry point.java. You will see another class also over here. You have demo C also over here. So now you have three demo C class. Demo C over here, like the top demo C. Then you have the Pokemon demo C, then you have the Beyblade demo C. So now if I want to, oh, and not main, I don't want this, by the way. I don't want main, I want the same method over here. Oh, this has this method. Okay, let me quickly change this. Actually, I wanted this method over here. Copy this. Let's say every demo C has the same method. Okay, this also, and this also. Let's recompile everything. Let's recompile all the demo C classes. I can say Java entry point dot Java. This will recompile the demo class. Let's compile the Pokemon demo C class. I can say rabbit Java rabbit slash Pokemon slash demo C dot Java. This is compiled. I can say rabbit slash Beyblade folder slash demo C dot Java. Compiled. So all of them compiled. Now let's try to import. Let's try to import over here. Let's say I import something as import. Say the Pokemon one. Say the Pokemon one. Okay. So import, or maybe the Beyblade one probably. Yeah. So let's import the Beyblade one. Import rabbit dot Beyblade dot demo demo C. Imported this. There is another problem. It is now showing the import rabbit.beyblade.demo C conflicts with a type defined in the same file, which is this. This will clash. This will clash. This will not let it happen over here. This will not let it happen. So what about I define it? You might say, what about you define the class C in a separate file? Well, no problem. Let's try doing that. Let's try doing that. Okay. Let's remove all these things. Let me recompile entry point. Javak entry point. Compilation done. And let's create a demo C. Okay. Demo C dot Java. Let's paste it over here. Oops. And of course public class demo C. So before we go any further, let me say it like this. From the top folder, let me quickly go through the folder structure once again, just in case you have confused this, right? I can say tree. Now look at the structure over here. So you have demo C at the top folder, and you have entry point at the top folder. Okay, good. You have the elephant package. Within elephant package you have the demo A class. You have the rabbit package. Within rabbit package you have the Beyblade package. Within Beyblade package you have demo B and demo C. You have the rabbit package. Within rabbit you also have Pokemon package. Within Pokemon package you have demo C and demo D. Okay, so my question to you is that when I go back to entry point and I say something like this. I say demo C dot this. I haven't imported anything. Remember, I haven't imported anything. Which one will be called? Which one will be called? Because I haven't imported anything. When I haven't imported anything, let's understand the structure first quickly. Let me give you a visual representation of what I am saying. And then we can go back to BlueJ and do our stuff, right? But it is very essential that you understand it in a bare minimum way. So you have your entry point, and you also have your demo C over here. Okay, then you have the elephants package, no use to us, at least at this moment. Then you have the rabbit package. Now elephants package directly has demo A. Rabbit package on the other hand has Beyblade package and Pokemon package. Okay. Now within Beyblade you have demo B and demo C. Within Pokemon you have demo C and demo D. Okay. So when inside this you are saying demo C dot what was that method name? Let me go back once. What was that method name? Demo C example. Okay, demo C example. Okay, let's go back. Demo C dot demo C example. When you're calling this, my question is which demo C will this refer to? You haven't no import statements, you haven't imported anything, you haven't imported this or anything, you haven't imported anything. So which demo C will that refer to? It will then, if you haven't imported anything, Java compiler will try to find demo C first inside its own folder. So where is demo C? You haven't imported any of the folders, you haven't imported this, you haven't imported this. So where do you see demo C? Will this use this? It can't. It can't. Why? You haven't imported it. Will this use this demo C? It can't. You haven't imported this. Can it use this demo C? Yes, it can. Why? Because it is in the same package. Now you will say, hey, but this does not have anything as package or something like that. Like you will say, for sake of your argument, you can say, I haven't defined any package over here. So what is the package? So when you don't define any package, Java compiler will put something like this. Package default. This is called the default package and you don't type it in. You don't get to write this. Java compiler will decide that this is a default package. Of course, because Java is our top folder. Like if I go back, this is our top folder. Inside this, then, oopsie, open this. We have all these things, right? Inside the Java, we have entry point, and so basically what I am trying to say is this. Java is our top folder and entry point is there only. So this is called the default package. When you don't define any package specifically, these are not default packages. This is the rabbit package, this is the elephant package, but this the outside, the topmost thing is called the default package. So Java will decide that this is default package. So now you will basically be using this demo C. You wanna see? Let's see. If I try to do this, let's go back to our coding area. Let's try to compile. Let's try to run this. Let's try running entry point or something. Let's compile this. Java entry point.java. Okay, compilation done. Let's try to run this. Java entry point. What do you see? It says hello from demo C from the top folder, which is mentioned in this. Hello from demo C from the top folder. That is which demo C is being used? This one is getting used. Not this one, not this one. Okay, the top demo C is getting used. Why? Because it is using the default package. So can I use maybe this? Yes, you can. How do you do that? Just import it. How do you import it? You can simply say import rabbit dot what was the subfolder? Beyblade. Sub package Beyblade dot demo C. Now what will this call? Now what will this call? Let's compile this. Let's compile this. Let's compile entry point.java. Done. Let's try and see which one it is calling. Is it still calling the top demo C, or is it now calling the Beyblade demo C? Java entry point.java entry point. Now it is calling a rabbit Beyblade. Okay, now this is no longer calling this one. It is now calling this one. Why? Because you have mentioned that you have to use rabbit.beyblade.democ. So it is going to use that only, not this one. Okay, so this is, think of it like a type of polymorphism as well. You are writing the same method name, and depending on which package you are importing, it is using that one. Okay, so this is another one kind of, like, think of it like a kind of polymorphism over here. One method with the same name, but defined in multiple packages. Okay, so hope the confusion is now clear. We are done with this. I am not going into more details. Like, of course you can do something like you can call this also and that also, but you know, let's not complicate it. Let's keep some things to find out for you only, or maybe I'll show it in a separate video. Now let's move on to BlueJ. Okay, now you are clear with how to compile, what are packages. Packages are nothing but just the folders, nothing else. What is the default package? Well, default package is when you don't define any package. Till now we haven't defined. Have we defined any package till now? No. So everything was in default package till this lecture. Like, think about this. Think about inheritance. Think about the polymorphism lecture. Think about the object-oriented lecture. Think about all the things that we have done before this lecture. Everything was inside the default package because we haven't specified the package name. So Java compiler decided everything is in default package. So that is default package. So it is basically folders where you can categorize classes. That's it. Now let's open BlueJ and let's finish this thing up. And let me clear the confusion also. Confusion regarding protected. Now I can actually show you what protected does. Remember the protected access specifier? Let's go into detail now. Now is the time that we can go and talk about protected. Now let's talk about this thing. So it's time. Say for example, again, this is your entry point. This is your top package. Say this is your top package. This is another your top package. This is your sub package. This is another sub package, and say this is your Java class. This is your Java class. Okay. So now, for example, say this Java class is class A. Okay, this is the class, and it has a method called, look at this carefully, protected static static void example. This is a method name example, and it does nothing. It just says system.out.println. It simply says hello. Okay, this is what it does. Okay, and we are done. Let's close the class. Say in the same package, in the same sub package, let's be more specific. In the same sub package, you have another class. Let's call this class B. Now, how would I access this? Would I need to import this, or I can directly access it? If it was public, I could have directly accessed it, but it is not public. So can I still access it? That is the question, right? Also another thing, can I access this method if I import it over here? Can I do that? See, I'm not going into private, though you anyway can't access outside of this class. Only if you define something as private, you absolutely cannot access it outside the class at all. Okay, so I'm not going into private, but can I do it? Let's see. Let's open BlueJ and let's check for ourselves if I can actually do it, and then we can conclude this video. Let's go back. Oh wow, it is 1 hour 10 minutes already. I guess the 30-minute duration I promise is not going to happen. BlueJ. And actually, you know what? Let's create a new, or maybe just remove all these things. Delete, remove. Okay, this is our entry point. Let's create a package. How do I create a package? Whenever you have created a new class, you have clicked over here. Now to create a package, go to the second button, edit, and then you will see two options: new class, new CSS file, new package. Create on this one, new package. Let's type the name, package name. Say for example, I cannot have some innovative name. Let's call it Vivek. Do you see? It looks like a folder. It is not a class. See, inside the package you will have like classes and everything. Like it looks like this, right? This is our first package. Let's say within the same package, I'm not creating any more packages. Okay, I'm not creating any more packages. Within the same package, now I can create a class and call it maybe class A. And let's create another class over here only. Let's call it class B. We have class A and class B. Okay, good. Let's go to class A and define a method quickly. See, did you see? BlueJ automatically understood that this is a package called Vivek. So it has written Vivek. Over here you have the Vivek package. Inside the Vivek package you have class A and class B. So anyway, let's try to do this. Let's remove all these things. I don't need all these things. And remove all this, everything. Let's create a simple method over here for Vivek. Say, let's start with public static void, and it will say example. Simple method. It only says hello. System.out.println hello from class A inside Vivek. Class A inside Vivek. This is inside Vivek, so I'm just writing it. So let's save this. Let's compile this. We're good to go. Now, inside class B, can I directly use it? Of course, I can directly use it. I can simply go on. See, this is also package Vivek. This is also package Vivek. Let me just remove quickly all of these things. Yep, perfect. Now you can go and simply say public. Say this is say public static void main and string args. Inside this, can you use that class A's example method without importing it? And we have been doing this. If something exists over here only, say there are many more classes over here, we did not need to import it. We can directly use it. So similarly, inside the Vivek package, you have class A and class B also. So class B does not need to import class. It is already there. So don't import it. And it is under static method. Don't need to create a object of class A. Just simply say class A dot what was that method name? Example. Okay, let's try and compile this. Class compiled, no issues. Now you see that it is using a method of class A. It is using a method of class A. What is that method? This is the method. Let's try to compile this quickly. Sorry, let's try to run the class B quickly. And by the way, let me, for class B also, let me say uh, system dot out dot println, just to avoid confusion, you know. Hi, this is class B. Hi, this is class B main method within Vivek. Just to avoid confusion, you know. Now let's again recompile this. Let's try to run this and run. Will this work? Yes, it is working. Hi, this is class B main method within Vivek. I mean this one, and it can actually access the method of class A. Why? Why? Because it is public. It can be accessed anywhere. It is public. It can be accessed anywhere. Correct? I have defined this this example method within class A as public. What happens if I make this private and try to compile this, and then I try to, this is done. Now I try to compile class B. It will not compile. Why? Because now this method is now private. It is saying example has private access in class in Vivek.class. I mean, if you define anything, listen to me very carefully. If you define anything as private, it cannot be accessed anyway outside of this class. Even if you say, even if you go and in class B and say class B extends class A, you might think this is inheritance. Will this work? This is inheritance. Will this work? It will still not work. Even inheritance will not work in this case. Why? Because I have mentioned that private static void example. So this method cannot be used directly or by importing or by inheriting. No way this can be used anywhere. So whenever you define something as private, it can no longer be used anywhere except in the same class. Okay, make that clear. Okay, what about protected? What about protected? If you say protected, this is inheriting this, and let's not inherit this. Okay, let's not inherit this. Will this work? I'm not inheriting class A. I'm just using this method without inheriting class A inside class B. Will this work? I'm not inheriting. I'm not saying class B extends class A. I'm not doing that. Okay, I'm just saying class A dot example. Will it be used? Can I use this? Let's compile this. Let's try running this. Yes, it is still working. As expected, it is working. It is still working. Okay. So first point clear. When you have a method or attribute, doesn't matter. When you have a method or attribute defined as protected, and you can access it anywhere within the same package. You can access it anywhere without importing and without inheriting. You don't have to inherit. So what I'm essentially trying to say is that, what is your current BlueJ folder? Say this is your BlueJ. Okay, this is a BlueJ. You have the entry point, of course. Forget about this at the moment. Okay. Then you have the Vivek package. This is the Vivek package. Inside Vivek package, you have a class A and you have a class B. Class A has a method called example, and this is in protected. Does class B has to inherit class A to use example? No. Does class B need to import class A to use it? No. It can it can directly access. So first things first, protected means can be accessed directly anywhere in the same package. Why did I say that? Because both class A and class A are inside the Vivek package. As long as it is inside the same package, it can be directly used. No need to import it, no need to extend it. Okay, great. But can this be used inside entry point? Well, let's see that. Let's try check it out. Let's go here and let's try. Okay, let's do this thing. Let's go back to class A and change this to public. Doesn't affect class B. Doesn't affect class B. Why? Because it is public. Public can be accessed everywhere. Okay, inside the package, outside the package. How do you access the how do you access the public? How do you access the public method example outside the package? Outside the package means here. How do you do it? And yeah, let me bring Vivek a little closer over here. Yeah, this is the Vivek package. How do you do that? Let's go back to entry point and yeah, just remove all these things. You don't need it. How do you use class A's example method? So it is inside the package now. You have to import it. How do you import it? You have to say import. What was the package name? Vivek. What is the class name? Class A. Oops. Class A. Done. Imported it. Great. Can you access it directly now? Let's see. Can you directly access it? Can you say class A dot example? Can you do this? And let's compile this. Class compiled, no syntax error. No syntax error. Let's try to run entry point over here. Will this work? Yes. Yes, it is working. It is working. Okay. Do you see this? Hello from class A inside. Hey, ignore this. This is previous output. Okay. This is previous output. Ignore this. But look at this. Look at this. It is working. It is working perfectly fine. It is saying hello from class A inside Vivek. It's working perfectly fine. So if it is public, you can just import it. If it is public, you can say, see this. If the method or attribute is public, if you want to use it outside the package, all you need to do is to just import it and simply use it. Very simple. Very simple. Public means you can use it everywhere, inside the package, outside the package. But if you are using outside the package, all you need to do is to import it and then use it, which is a common sense, basic. Like, but point is, what happens if you remove public and set it to protected? What happens then? Now if I compile this, will this work? I have to compile this also, of course. And you know what? Let's remove all this stuff and everything. Compile this. Yeah. Okay, this is done. Class B is not needed. Now when I go to entry point and compile this, will this work? This will no longer work. Why? Example has protected access in Vivek class A. You cannot access a protected method or attribute outside its package. Okay, there's another point. Another point, cannot be accessed outside package directly. You cannot access it directly, not possible. But it is still accessible. How? Still accessible how? Well, if you see, you have imported it. See, this is the first step. You have to import it. Anyway, you have to, if you are using, it is a common sense. If you are using a class which is inside another package, you first have to import it. This is the basic thing. But the problem is that this method over here is not public, it is protected. So to use this method, you basically have to extend the class. The moment you say extend class A, extends class A, the moment you do this and compile this, now no error. Now no error. Did you see? Now no error. So point is, protected will allow the method to access outside of the package. Yes, outside of the package, only if and only that class is inheriting it. So basically, a child class, any child class will be able to access this method. Any child class would be able to access this method. Now if I try to compile this, it works like a charm. If I try to run this, works like a charm. No issues at all. This is working. So this is the third point for protected. We take it over here and child classes, child class or subclass can access the protected methods or even attributes. Simple. Child class or subclass can access the protected methods and attributes irrespective of the package. Irrespective of the package. What I mean by this line is this. This is protected. Okay. Now say for example, class B inherits class A. If it does that, can it access example? Yes. If entry point extends class A, can it access this? Yes. Why? Because this is protected. The moment you inherit this class, you can access all the protected properties and public properties. Private properties, no, you cannot do that. But protected and public, yes, you can access it. Okay, that's the thing. But here's the special thing. Since class B is already in the same package, it does not need to inherit it. It can directly access it within, like it is accessible anywhere in the same package. So class B does not need to inherit it. Yes, it can inherit it, of course, and that is not wrong if it really requires to. But even without inheriting this protected method can be accessed by class B, not by entry point. This is outside the package. It cannot directly go ahead and say class A dot example. That will not work. The moment this inherits class A, only then this example method will work for entry point. That is the concept. So 3 points for protected. It can be accessed directly anywhere in the same package. It cannot be accessed directly outside the package. Directly, so not possible. But child class or subclass can access all the protected methods and attributes irrespective of the package. The moment entry point inherits class A, it can access all its protected properties and attributes. So that's it for today's video. That's all about packages. So in the next video, we are going to cover two things probably. First thing is arrays, and second thing is oh no, that's still pending. So in the next video we will be rather covering let me think, yeah, abstract classes and interfaces. We'll be covering both of them. We'll be covering abstract classes and interfaces. So see you in the next video. Bye bye.